This is the fifth and last video in my series on instrument transformers. In this video, I will be looking at capacitor voltage transformers. You can find out more on these subjects in my course entitled Electrical Three-Phase Power Transformers Fundamentals. You can access this and my other courses on my Stan store at this web address.
Another type of potential transformer that's in common use today is the capacitor voltage transformer, or capacitor coupled transformer, and sometimes designated as a CVT or a CCVT. A capacitor voltage transformer is a transformer used in power systems to step down extra high voltage signals and provide a low voltage signal for metering or relaying operations. In its most basic form, the device consists of three parts: two capacitors across which the transmission line signal is split, an inductive element to tune the device to the line frequency, and a voltage transformer to isolate and further step down the voltage for the metering or protective relaying device. The tuning of the divider to the line frequency makes the overall division ratio less sensitive to changes in the burden of the connected metering or protective relay devices. The device has at least four terminals, as shown here. A terminal for connection to the high voltage signal, a ground terminal, and two secondary terminals which connect to the instrumentation or the protective relays. In practice, capacitor C1 is often constructed as a stack of smaller capacitors connected in series. This provides a large voltage drop across C1 and a relatively small voltage drop across C2. As the majority of the voltage drop is in C1, this reduces the required insulation level of the voltage transformer. This makes CVTs more economical than wound voltage transformers under high voltage conditions, such as anything over 100 kV, as the latter one requires more winding and more material. On schematic drawings, CTs with their polarity markings look something like this, representing the concept of an actual CT. On schematic drawings, PTs with their polarity markings look something like this, representing the concept of an actual PT. This is an actual standard drawing using PTs and CTs with their polarity marks and connected to give the right measurement for a kilowatt-hour meter. You can see the CTs are connected on the lines. They are in the bold type line drawing there, and they have spot markings like a little square on the primary as well as the secondary. The potential transformer is in thinner lines there just to the left, and the spot markings are actually X's on the various terminals of the potential transformer. This is another example where a differential relay protection is on a delta to Y transformer. The spot markings of the instrument transformers, the CTs in this case, are very clearly visible, and including the spot markings of the power transformer for which it is protecting. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to.
One of those products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra. The 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra is one of the most versatile whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use. With an unrivaled capacity of 6 kWh, 7,200 watts output, and 5.6 kilowatts solar input, a single unit can run your entire home. With 𝐃𝐈𝐒𝐂 Smart Home Panel, you get an uninterrupted power backup experience with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation, but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors, and it is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes. Compatible with various energy sources, from solar to gas, to meet your ever-changing power needs. To obtain a discount code for 5% off on all 𝐃𝐈𝐒𝐂 products and more information on this subject, and pick up your free digital copy of The Ultimate Guide to Residential Standby Generators. Simply fill out the information requested when you go to this website, https://bit.ly/3w/3v_e_r_h.
Before we end this video, I want to repeat the connection to my free copy of the Ultimate Guide to Residential Standby Generators and the 5% discount code for all 𝐃𝐈𝐒𝐂 products. Also, here is the connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my stand store.